table, you're going to fill in the blanks that are missing from the outside of your area model. So you're basically factoring that. Once you finish those, answer these 2 questions. Take about a minute. Shouldn't take us more than a minute. So, what were the top 2 values on that area model?
X is 4.
X is 4. And the side?
X is 5.
Alright, what was the polynomial represented inside your area model?
Is it like x squared? X squared plus 9x plus 20.
Very good. Okay. So the entire equation, so the center was x squared plus 9x plus 20, and that would be the equivalent of
X plus 4 times x plus 5.
Very good. Okay, so that's exactly what we did yesterday, right, with factors, but we used tiles. Today, making that transition over to using the area model without using tiles. But I want to kind of discuss, when we're factoring polynomials, but we're getting into factoring quadratics, right? So the standard form of quadratics is ax squared plus bx plus c, okay? And this is going to be important for us when we start factoring, because I'm going to talk a lot about a and c, sum of b, things like that. So we need to be able to identify what is the a value, what is the b value, what is the c value. Yep, everybody pretty good with that? Okay, so if that's the case, looking at my first example, what's my a?
X squared.
No.
Wait, oh, 1.
1. So a would be 1. It's the coefficient, right? It's kind of like standard form of linear. You have ax plus by equals c on linear. The a value is not the x, it's the coefficient. What's the b value?
6.
C?
5.
Okay. So just kind of have that in the back of your head as you go through a lot of these. So yesterday, we used tiles, but where did we start? How did you start factoring? Like, what did you set up first? Okay, that we set up, it was kind of the inside, right? But which term do you start with? X squared, the first term. So you start with x squared still, but then what was the next term that we looked at? Was it the center? No, it was the last, and then the last term. So you're going to do the same thing. Now when it comes to that diagonal, we're actually going to look at not just your c value, but we're going to multiply a times c. So in this case, a is 1, c is 5, so will it really make a difference of what the value is? No, but sometimes it will. So what's a times c? 5. So we're going to look for factors of 5 that have a sum of 6 because of that center term.
1 and 5.
Okay? It's the only way you can multiply and get 5, right? And lucky for us, it adds up to 6. So I'm going to take this 5x and 1x, and I'm going to place it. How many empty boxes do I have left? 2.
I'm not getting this.
We're going to do a few more. Because remember when we were dividing, and you got the bottom left box first, and then you had to use the center term to figure out how much you needed to keep going? It's kind of a similar thing. You know that you have that center term that you need to have the sum in the diagonal. So we're going to be using different factors to get there. We're going to do a bunch together, so don't stress it. Okay, so now, just like you did with the warm-up, do you have enough information to find your factors? Yeah. What can I divide out of x squared and x? x. What can I divide out of 5x and 5? 5. Okay, so now for the left. What can I divide out of x squared and 5x? X. And what about x and 5? 1. So when I rewrite this, I've got x squared plus 6x plus 5 is equivalent to what? X plus 5 times x plus 1. Right, so we're doing this reverse thing when we multiply polynomials, we're going the opposite direction. Now we're factoring them out and getting them back to that factor form. Alright, so let's flip on over. We just did a bunch of stuff, but I actually neglected to do the first step, which is the most important step, because we didn't actually need to do it on that. But the first step on any factoring problem is you're going to look to see if you can factor out a GCF. Now, on that one that we just did, there wasn't a GCF to factor out, so it wasn't possible. It's not always going to be possible. But if you can, it's going to make it so much easier. So first thing, factor out a GCF. What was the second thing that we did? Okay, you have your area model. And then once you start with the first term. And then what did we do?
Last term in the bottom right.
Good. And then we did some fancy business to get the center, right? So what we did first was we multiplied A times C. Then we used that, and we were looking for factors, or finding factors of A times C that have a sum of which value? B. Very good. Have a sum of B. Okay, then when we found those factors, we placed those found factors in the empty squares. And then finally, we factored. A lot of writing today. Sorry. That's it though.
Yay.
Alright, so let's put this into practice a few times. Number 1, what's A?
X.
Ah,
Negative 5.
Is
1. What's B?
Negative 5.
Negative 5. What's C? Negative 14. Can you factor out a GCF? No. We should have actually addressed that first. You can't factor out a GCF. So, first term, first box. What's my first term? X squared, last term, last box. Very good. Okay. Now, what's A times C? Negative 14. And we need factors of negative 14 that have a sum of negative 5. Good. So since it's negative, one of them's negative and one of them's positive. And since it's negative, the sum is negative, it means the larger value is the negative value. So 7, -7, and +2 are what we're going to choose. So we're going to put those in those empty boxes. So -7x and 2x. Do I have enough information to factor?
Yes.
Yep. Okay, what are my top two values? X minus 7. What are my side values? Very good.
Thank you.
So we're going to rewrite it now. X squared minus 5x minus 14 equals.
X minus 7.
Very good. It's not bad, right?
And not really.
Okay, number 2. Can you factor out a GCF?
Yes.
What?
2.
2. So we're going to rewrite it. 2 times what would be left? Huh?
Wait, what?
X squared plus 7x plus 12. Okay, now when we start to factor, we're factoring what's left. You factored out the 2 already, so we're not worried about the 2. That doesn't mean it's gone. It's going to come back at the end, but we don't need it for right now. All right? So now, based on that, what is your A value? 1. B. C. Okay, what is A times C? 12. Okay, we need factors of 12 that have a sum of. Okay, so my factors are 12. 12 and 1,
4 and 2.
6 and 2, 4 and 3. Which one has the sum of 7?
4 and 4.
Okay. Now, first term, first box. Good. Last term, last box. Okay, what goes in the other ones? Very good. Do I have enough information to factor? Yeah, buddy. All right, what are the top two values? X plus 4. Side. Okay, so now we're going to rewrite it. But, rewrite the original problem. 2x squared plus 14x plus 24 is 2. There it is. X plus 4 times x plus 3. If you forget the 2, are they equivalent? No. Alright. Let's look at number 3. Can you factor out a GCF? No. What's A? B? C. Very good. A times C. 20. I need factors of 20 that have a sum of what? Negative 12. So I've got 20 and 1, 10 and 2, 5 and 4.
Negative 10 minus 2 or -2.
Negative 10 and negative 2. Good. These are what we're going to use. All right, so first term, first box.
4x.
Thank you. Last term, last box. What am I going to put in the other two?
-10.
Uh-huh. And
2x.
can you pull from 4x squared and negative 2x? What's the greatest common factor of those two? 2x. What about negative 10x and positive 5? Oh, 5. Negative 5.
Whoa. Good call.
Okay, side.
2x minus 1.
Very good. So, when I rewrite this, 4x squared minus 12x plus 5 equals
2x minus 5 times 2x minus 1.
Why do we rewrite the whole thing?
because eventually you're going to solve it. It's already going to be equal to something. But you want to write it as an equivalency. Okay, last one we're going to do together. Can I factor out of GCF?
Yeah.
What?
8.
Good. What's left?
X squared plus F plus 1.
Okay, so what's A? 1, B,
1.
C.
Negative 20.
Good. What's A times C?
Negative 20.
Negative 20. So I need factors of negative 20 that have a sum of what? 1. So neg 20 and negative 1, would that work?
No.
10 and negative 2, 5 and negative 4.
Yes.
Okay. First term, first box. X squared. Last term, last box. What am I going to fill into the other two?
5x.
Okay, good. What can I factor out on top? X plus 5. What can I factor from the side? Okay, so 8x squared plus 8x minus 160 is equivalent to 8 times. Very good. Okay, so before you leave, we are going to check the back of that page. Then your homework will follow. If you finish this page before we check, I wouldn't sit and just wait. I will work on my homework. Okay?